So let's start by, I'm gonna remove the ground plane for now. I'm gonna disable these two. I'm not gonna use them for a moment, just reconnecting without that. And I'm also gonna go to the pop solver and disable this option to add it attributes. And let's get something to collide with. So I'm gonna go all the way up. Let's create a test geometry. Test geometry, it can be a big head. So now we have a big head, and we'll have our particles collide with this big head. On our big head, I'm going to dive inside. I'm going to set the difficulty to easy, so it's just not as high res. Or we can leave it at medium, but just disable the shader. Now our particles should be falling on top of this. And let's see how we can actually use this object as a collision object on our particles. So let's go to the pop demo. So what we'll usually do is feed the object that we want to use as a collider directly into our DOP network. So we'll create an object merge. I'll just grab the big head with this object merge. So we have the big head here, accept. And I'll feed this into the second input. Now, one way of dealing with collision is by using a pop collision. You have pop collision detect and pop collision behavior. Let's explore the pop collision detect. The pop collision detect will give us several options. Let's start by configuring the essentials. So the collision target is going to be our second context geometry. So this is referring to the second input. Let's make sure that, yep, everything's fine. And then as soon as this is on, we can actually see let's go here. And this is what's happening. So as soon as we have that, what's going to happen is by default, it's going to be colliding, detecting the collision, but it's not doing anything. So the pop collision detect right now, the behavior is just colorizing whatever particle that hits that object. It's not gonna have any response. It's just gonna be colored to red. But as you can see, it's really fast to calculate. We're throwing a lot of particles at it, and it's really, really easy to. It has no trouble at all in calculating this. Now, what other options do we have? So here on the response, we can say they die, we can say they stop, they stick, or they slide. So if I turn off die, as it says, they're just being eliminated as they hit. If we say they stop, they're going to be accumulating on top of that surface. Okay, we have a bunch of particles being accumulated on this object. Notice that some of the particles are actually inside the surface. They don't seem all to be on the same plane. And the reason for that is we're calculating per frame. So on one frame, it may not be hitting, but on the second frame, it may already have hit, but gone through the surface, and they're just stopping wherever they are. This option of move to hit will make sure that they're all back. They all move back to the position on the surface where they actually hit the surface. And this gives us a more what you might expect from something like that. Okay, so they return to the surface. They won't stay inside. The other option we have is stick. Same thing. Basically, it just means that instead of stopping, they're actually going to stick to the surface in case the surface is actually moving. Let's add some animation to our pig. Let's go up. And here on the test pig geometry, I'm gonna just create some expression here on the rotate. We can, for instance, add a bit of a rotation here. Let's say frame times 5. And as you can see, it rotates. Now it rotates. All we need to do is make sure that when we import the object here, we say the transforms into this object so that it rotates as well. And here on the object on the pop network, we should see, so here in the collision, we don't really need to use the forming geometry. It's just going to be animated. It should be faster. But as you can see, it rotates. And with the option of sticking as a collision behavior, the particles will stick to the surface. If we, instead of stick, we use the stop, they're just going to be stopping, but they're not going to be sticking to the surface. Okay. Now, the other option will be the slide. And the slide option is actually pretty useful. In a lot of cases, this is usually enough. Notice this note, bouncing is handled using static or RBD objects. So we'll get to that later. But if you don't need your particles to bounce off the colliding objects, then you can deal with just a pop collision detect and work with these responses. So the sliding, what's going to do is exactly what it says. So the particles are going to slide along the surface and fall. Okay, also a very useful option if you don't want to color them. Let's just have them keep the color. Okay, so this solution is great for when you don't need bounce. But let's say you actually need them. You really want them to bounce off the object. Let's see how we can do that.